Let's get started. I think we have people already waiting in the room. We're a couple of minutes over. We have 3/4 of our panel here, so that's 75%. That's good enough to get started, I think. So welcome everybody that has come to this panel session on steel, and specifically green steel, how we're going to decarbonize this important industrial sector. I'm Rosie Barnes, and I've got a YouTube channel called Engineering with Rosie, and I also run a consulting company that works with clean tech investors and developers called Partalote Consulting. And I'm in Australia, and so it's 5:30 a.m. here for me, and I didn't get up in time to watch the keynote earlier today, but I understand that steel has already been one of the topics raised in the keynote. So I hope that you're all excited to hear about solutions to the big decarbonization problem that is steel. So we're going to have 3 panelists here today. I'll introduce them really briefly now and then give them a minute to introduce themselves in better depth later on. So we've got Andy Zhao. He's a CTO and co-founder of Limelight Steel. And you guys have all got really complicated last names to say, and I didn't practice them, I'm just realizing. And Adam Rowding, Senior VP of Business Development at Boston Metal. And shortly we'll have joining us David Livingston, who's a Senior Advisor with the US Special Presidential Envoy for Climate. And how did I go with the last names there, guys? Was it recognizable? Okay, cool. So everybody who's here watching, can you tell us in the comments where you're watching from, like where in the world you're watching from, and why you're interested in green steel? I'm not 100% sure what the mix is going to be in terms of, people working in the steel industry or people that need to procure green steel. So if you can tell us in the chat, then that will be good. And I've also hopefully posted a poll question in there. How far away is green steel? So let us know what you think about that, and maybe we'll ask it again at the end and see if anybody has learned or changed their opinion about that after today's talk. So I think the reason I was asked to make this panel, moderate this panel, was because on my YouTube channel I recently made a video on green steel, and actually I've got a couple more on related topics coming out soon. Basically I wanted to make it because steel is a really important industrial material and responsible for about 7% of global emissions, or some estimates go up to about 10. So that's a big chunk. And because steel is an easily and economically recycled material, already most steel is recycled at the end of its first life. But because the global demand for steel is growing, this isn't going to be enough to take us into a zero emissions steel industry in the future. And a lot of the expansion in steel demand is because of the expansion of clean energy technology. Steel's using a lot of clean energy products, like wind turbine towers is one of the biggest ones, and also solar farm bases and a few other green techs. And because of this growth, even if we recycled 100% of our steel scrap, there isn't going to be nearly enough to supply global demand over the coming decades. And I also think that steel is an interesting topic because it's not so easy to understand the decarbonization solutions as it is for other industries where it's just a matter of cleaning up the electricity grid, because steel involves taking iron ore, which is, iron and oxygen atoms together, and you need to get rid of that oxygen. And traditionally that's been done by adding carbon to it, which reacts with the O2 and makes carbon dioxide, which goes off into the atmosphere. So you need to find a different way to do that. And I've got some experts today that are going to tell us in detail about how those work. But basically you can substitute the carbon for a zero emission source like biomass. And some companies are looking into that already. The big one people talk about a lot is hydrogen. You can use the hydrogen to react with the O2 and make H2O water instead of CO2, which is obviously less harmful to the environment, once it comes out of the atmosphere anyway. And then there are direct electrification routes. So I think Adam can talk more about electrification, and I know that Andy knows a lot about the hydrogen side of things. Yeah, so that's just like a really quick overview of how what the technology options are basically, but I'm not the expert. The panelists are. I did just first of all want to share. I've got this chart actually from Boston Metal, so maybe it looks familiar to you, Adam, if you can see that, which is about the large steel makers, global steel makers, and their emissions reductions goals. So yeah, you can see a lot of most of them have these 2030 goals that are for a partial reduction in emissions and net zero goals in 2050. So it seems like the industry is on board, and I'm keen to find out from the industry experts about how we think we're progressing towards that. So now I'll just get onto the better introductions from the panelists. So let's start with Andy, and if you could just tell us, a bit about who you are and what aspects of the green steel transition that you're interested in.
Yeah, I just have a few slides as well, so I'll start with that. Can you see my screen okay? Yep. So I'm at Limelight Steel, and we are on a mission to provide zero emissions steel and make it a reality. So just a little bit about me. I'm a material scientist. I did my undergrad at Stanford, and I just finished my PhD at UC San Diego studying clean industrial heat, how to provide high temperature heat for industrial processes without burning fossil fuels. And I also had a project on high power laser materials. That's a precursor for later. As Rosie already said, there's 1.5 billion tons of steel made every year. And for every ton of those, about 2 tons of CO2 are emitted. And that demand is going to increase to 2 billion tons per year by 2030. So the way I like to frame it and think about it is, where is that demand coming from? It's from new countries industrializing in Southeast Asia and in Africa, where the largest cities of the next century are going to be built, where they're going to be building aqueducts, bridges, and skyscrapers. And they're going to have to build that with something, and it's going to be steel. So what are the technologies that they have today? And this is the most, I guess, ubiquitous source of steel today, where you have a blast furnace and basic oxygen furnace. So those countries, when they look to options for industrialization, they're going to find the cheapest option that can provide millions of tons of steel per year, but that emits CO2 for every ton provided. So there's been some alternatives, I guess, suggested and built over the past few decades, primarily direct reduced iron. So still using fossil fuels, but cutting the emissions in half, where you can produce direct reduced iron to feed into an electric arc furnace to be melted down. This is slightly more expensive, and it's at a smaller scale than the blast furnace technique, but this is the primary route that steel makers are planning to meet their goals. And the analogy that I've been playing with is those steel makers could be thought of as the automakers from 10 to 15 years ago, where they are going to increase their efficiency. They're going to capture some of their carbon to reduce the emissions. But we need kind of a step change and a breakthrough in technology to make green steel available ubiquitous. So I don't know if you guys have heard about a project in Sweden called Hybrid, but they used green hydrogen, fossil-free steel to make the world's first green steel, which is super exciting in just the past year. So the answer to the poll question is, green steel is here today. There's just 2 big hurdles to overcome. One is cost, where they had to find an off-taker for steel that is more expensive. So Volvo was their off-taker for the more expensive steel. And the second is throughput. You need to be able to produce enough steel to build out a city, to build all of the construction that a lot of people in the audience are experts in. And the limits are throughput. It's about 1 ton per hour for them. And the ArcelorMittal and other steel makers are planning to have hydrogen demonstrations on the order of 100 kilotons per year. So still 3 orders of magnitude too small. So this is just a briefer on very, very brief introduction on Limelight Steel. and how we plan to electrify steel. So normally it takes 4 to 8 hours in a shaft furnace to reduce iron ore into DRI, direct reduced iron. Our value proposition is we can do that in less than a minute to produce molten iron rather than the solid direct reduced iron particles. So by drastically reducing the amount of time and producing a molten material, we're able to cut the amount of energy it takes to make green steel by 39 to 54%, depending on which technique you're comparing to. Seriously, even any green steel producer, they have to compete as well as they can with the blast furnace on cost, on throughput, and emissions. So those are the key goals. Just an analogy that I like to think of for our process. So we're building a laser furnace. So how do we achieve those energy efficiencies? We are building an array of millions of laser diodes tuned to rapidly process iron ore. And that is extremely technical. You guys don't need to know the technical detail. Unless you're interested, you can ask in the Q&A. But if you want to electrify steel, you could use normal industrial electric heaters where you run current through just metal, and you're emitting infrared light similar to a toaster or a kitchen oven. And it would take hours to cook your meal. We are essentially making a microwave for iron ore where we are emitting the exact wavelength of light that iron ore likes to absorb. So iron ore is red, which means that it reflects red and infrared light. So normal electric heaters do not heat iron ore efficiently. So we are essentially converting clean electricity into the wavelength of light tuned to rapidly process iron ore to get those energy savings in clean steel making. I literally just found these images on Google just before this, but I hope that helps to understand it.
That's great. Thank you. I thought that was your very clean kitchen that you took photos of. So yeah. Okay, cool. So I just wanted to quickly go back to the poll. How far away is green steel? So we've got a split between 10 years away, and it's here now with a little over 40% each. So yeah, I think that's interesting. And I also just wanted to share one other thing, which I'll post a link in the description. But if you want to check out what the manufacturers are actually doing, and actually that reminds me, I just posted another poll about will the major steel manufacturers meet their 2030 and 2050 commitments. You can head to this this steel tracker and have a look. So you mentioned the hybrid, or I don't know, it might be called hybrid if it's Swedish project, and that's here. Fossil-free steel, hybrid fossil-free steel demonstration plant, and you can get some information about their throughput and stuff like that. So I think this is a really, really cool tool to have a look at what companies are doing. Have a look, a few in Australia here as well. Yes, okay. I'll put the link for that in the description in a second. And we might head over to Adam now to tell us a bit about who you are, who Boston Metal is, and what you're doing. And try and keep it quick so we don't run out of all the time. I also wanted to mention that. Sorry, just quickly before you start, in the chat we've got people that are calling who are people who are watching in two groups. It seems mostly. One is people that buy steel and want to reduce their that want to reduce their scope 3 emissions, so they're keen to see how they can do that. And second is a group of people who are just really interested in a non-electricity branch of the decarbonization journey. So yeah, keep that in mind. And over to you, Adam. Thanks.
Sure, very good. So I'll share my screen here. I'm Adam Rowdink, lead business development for Boston Metal. Been with the company for about 5 years, since 2017, leading both our fundraising and investment and corporate actions. Can you see my screen? It's flickering for me, but hopefully it's clear for you. So our mission at Boston Metal, similar to what Andy and what this whole panel is about, is decarbonizing steel. We also do that through electrification, taking coal out of the process, taking carbon out of the process, using clean electricity in its place. And Andy introduced the idea of the blast furnace, and the idea of using coal, and that's really been in the industry since the Iron Age, but encouraging to Andy and to I and to others trying to innovate in this sector. The industry does have a history of relatively rapidly adopting new technologies, and that happened throughout the 19th century. Still using coal in all of these, or carbon rather. But as new technologies came to market, they were adopted different ways to convert from liquid iron to steel. One example that you might hear about in the news with the open hearth, which was the technology in the mid-1900s. There's just a few of those left in operation, or were in recent operation, kind of right on the Russia-Ukraine border. So there was some very relevant news as of late, right at some of those old steel plants. But now, largely replaced by the basic oxygen furnace. Any of the integrated mills you visit today, you'll see that technology, or you'll see the arc furnace for melting scrap. And as Andy introduced, a bit of direct reduction that we often talk about, that being limited to quite high-grade iron ores. I've been to SSAB's plant way up in northern Sweden. They have premium-grade iron ores coming out of LKAB and in the north of Sweden. Lots of work being done, certainly, to expand the scalability of that technology, but in the fashion that it exists today with the direct reduction in the arc furnace, pretty limited on the ore grades. But what you see is an industry where when new technologies come to market, they can be adopted at very high penetrations. And as you go through the next couple decades, by 2050 through decarbonization, you're going to have to see a similar approach. You may see some work with the basic oxygen furnace to retrofit that, to use alternative forms of carbon, to use some carbon capture, but you're still going to be exposed to mining metallurgical coal, which is going to be a very volatile market, and you still have fundamental emissions there. So you either need some form of storage or a heck of a lot of utilization for your carbon. We at Boston Metal, and I think I can speak for Limelight on this, is that our approach is to get the carbon out of the equation, solve the core problem at the heart of that, and we do that through electrification. In our case, we're doing electrolysis directly on iron ore. This is at high temperature, 1500, 1600 degrees Celsius, so making a direct molten iron, very high purity product. As a byproduct, since there's no carbon, you're just getting oxygen as an emission, so no scope 1 emissions at all. And if you're using clean power, your scope 2 is also at 0. So you can go from that 2 tons of CO2 per ton of steel to a level of nearly 0. We've got a great team behind us today, picture of most of them there. And they're standing on and in front of our largest reactor that we have today, a furnace that's coming online in this quarter. We'll produce kind of at the tonnage level for steel production, and prove out all the core concepts as we move to do a demonstration plant in the middle of this decade. Rosie visited us a few weeks or a month or so ago, so it continues to grow. This probably looks a lot more advanced than what you even saw a few weeks ago. So that's our latest system. And as part of that as well, tapping green steel right in a commercial setting in Greater Boston. So still working to scale up. 2025, as I said, is our milestone for the first commercial demonstration plant, but already pouring green steel and a lot of growth ahead of us.
Awesome, thanks for that. And I did really enjoy my visit there. The coolest thing about Boston Metal is that you go up, you think you're heading to like a big dirty industrial facility, but it's actually in a business park and everything's super clean. Obviously, when they're tapping the steel, I wasn't there for that, but that must make a bit of mess, surely. But in general, it's not like if you go to the steelworks near where I live. Is one at Port Kembla, Blue Scope Steel, and that is big and smelly and dirty and noisy. And Boston Metal isn't like that. There was a lab part where they're making green steel in these like little tiny crucibles. So yeah, it's really cool to see the future doesn't have to look like the past. And that's actually perfect timing because we've got David has managed to join. Welcome, David. Technical problems. Glad to see you got it resolved. We can only see from your mouth up. So if you could tilt your camera slightly, then that would be easier. Yeah, perfect. Cool. So we're just gone through introduction into green steel and into the other two panelists, Adam and Andy. And if you could just take a couple of minutes to really quickly tell us about yourself and what your involvement in the transition to green steel is. You're muted. More technical problems. I can't unmute you. Well, Amelia is watching for technical assistance, so I will let her help you with that, and I'll move on to something else and come back to you. So I just wanted to talk about some of the polls that we've done. I put up another one. Will the major steel manufacturers meet their 2030 and 2050 commitments? And it seems currently in the lead is only 2050, which is actually also what I put, because I haven't seen a lot of announcement from the really big steel manufacturers about progress towards 2030. Maybe Rio Tinto, I saw that they're using biomass, but it did have the hint of an announceable rather than something that they're actually doing at scale to, because if you want to reduce your emissions by 30%, that means 30% of all of your emissions, not just one pilot project where you one time substitute some coal with biomass, right? So I just wanted to ask, what do you other panelists think about that? How do you see those targets that, most people are saying 30% reduction by 2030 and 100% by 2050. Which of those do you think that we're on track to meet? Yeah, sorry, everyone's muted.
I can take it.
Okay, great. Yeah, you go first.
I can take a crack at this, and Adam, feel free to jump in.
Yeah.
So the 2030 goals, I think cutting 30% of emissions is very doable with existing technologies, with DRI processes using coal and natural gas. So there are furnaces that exist to produce millions of tons of steel that is 30% less emissions intensive than blast furnaces today, which is why most of the steel makers today are comfortable with that the next 5 to 10 years in transitioning to DRI processes. And I think David actually could probably speak more to this.
While they're looking for the mute, I'll just say as well, the one thing that certainly benefits and I think makes this transition unchangeable at this point is just the momentum on the downstream side. And David and the State Department are doing a lot of work on that, on first movers for procurement of green steel, whether that's automotive, that's construction, that's public procurement, that's furniture companies, that's any consumer goods. You're seeing that, and that's in turn driving the steel makers. And as Andy said, they can do incremental improvements to get to those 2030 goals, but it's a complete revolution of the infrastructure that they're using today. And some of that will just, as you look at how much steel infrastructure is in the ground, the life cycles of those, there's a natural timeline that's going to flow through as you reach end of life for an existing blast furnace or major maintenance decisions that, hopefully the technologies like Limelight and Boston Metal and others are to market and at a proven point where when a blast furnace comes on ready for relining in 2032, you're putting 2 million tons of capacity from electrification in place rather than relining that blast furnace and locking that in for another 20 years.
Yeah. Okay, that's interesting. And I wanted to talk today about how the transition to green steel is going to play out, because I know that when I started getting interested in this topic, and the guy that I interviewed for my video on it, Bart Kolodejczyk, who was working with Fortescue Metals, he really surprised me with the technology, because all I had been hearing about was hydrogen. And in fact, that was the whole reason why I wanted to make that video, to make a video about something useful people were doing with hydrogen. Is that but by the end of the video making process and the research that I did, I became more convinced that hydrogen is a good near-term technology. We've got challenges because there isn't enough hydrogen and won't be for the foreseeable future to really quickly decarbonize large chunks of the industry using hydrogen on its own. And it seemed to me that in the future, we're going to see a mix of technologies. And I'll ask you all to comment on that, how you see it playing out. But first, I just wanted to mention a couple of questions that we got from viewers. So from Arlene Sherritt, can the steelmakers switch to electric arc furnace at a reasonable cost and reasonable equipment changes? Is this still a good option to reduce some emissions today? Yeah, I'll just ask this other one so that I can get through them quickly. Carl Kraus asks, on the topic of green steel availability, sure, it's here now as a proof of concept, but green steel at scale to meet capacity is still a ways off. No. Yeah, so can comment on those, and I will just check back in with David if he's been able to unmute, and doesn't look like it. Do you know sign language, David? You can do that Bob Dylan music video thing where you just hold up panels with what you want to say. Okay, so I'll go back to whoever wants it out of Adam and Andy then. How do you think that the green steel transition is going to play out, and with reference to what's happening right now, what companies can do right now to, not have to just throw out all their blast furnaces and replace them with new equipment?
Well, there was a question there on the arc furnace, and that's one thing you're seeing very rapidly, and that happened a few decades ago in the US, the move to about 70% arc furnace. So we have some quite green steel here in the US because of the high prominence of recycling. But globally, you're seeing a big push towards that as well. Even in China, huge growth in arc furnace and scrap availability. What's limited though is, today if 30% of steel is from scrap, and these are probably statistics people have heard, but the two big limits are the availability of the quantity of scrap that's available, and then the purity levels. If you're going to make high grade steels for automotive or bridges or any of the material efficiency side of things, which needs high grade steels to use less steel in each application, to do that, you need units of steel that have come from ore. You can blend that with some scrap for some applications, but you still, in any case, need, for quantity and quality reasons, steel that comes from ore. So today, if scrap is 30% of the market, there's forecasts that have maybe by 2040, 40%, or 2050, 40% of the market coming from scrap. That leaves a billion and a half tons that needs to come from ore. And we think electricity is the way to get that done.
Yeah. What do you think, Andy?
Yeah, I mean, Adam hit the nail on the head. The one thing I'll add is, I think someone asked about what are the other low-hanging fruits for steel makers to decarbonize now, because I think Limelight Steel and Boston Metal are, I think, playing the long game of, in 10 years, how do we get up to scale to produce millions of tons using new furnaces? But with existing furnaces, there are ways to cut emissions. This is kind of the analogy I was talking about with like increasing the efficiency of an internal combustion engine. Like there are ways to capture more CO2 coming off of the shaft furnace, but at the end of the day, like that will get you to the 20-30% cuts that you need, but it would cost a lot of money. So it's what do those steel makers want to invest in?
Yeah, okay. So let's move on to a related question then. What are the obstacles standing in the way of, decarbonizing really quickly? And I know, Andy, you mentioned hybrid, and that they needed somebody to buy the steel at a premium, to recognize that. And I mean, I agree that I can't remember who said it, but that consumers can demand that. So this suggests that they're willing to pay a premium, and I see that in all kinds of areas of the energy transition where consumers are making a difference. Like IKEA are using zero emissions deliveries in some regions now because people demand it, and I think Amazon as well. And Google's moving towards 24/7 renewable energy because they see that it's worth spending money and going through the pain of dealing with those new technologies they need to get there. So I guess price is one obstacle. What are some of the others for the hydrogen route? I guess hydrogen supply is, I don't know if certification of green steel is a problem, because obviously you take a chunk of steel, you can't tell how much emissions came from its manufacture. What do you guys see as the biggest obstacle? Maybe we'll start with Adam on this one.
The biggest obstacle, sorry, what was the biggest obstacle to
decarbonizing fast? And I know at Boston Metal, you're focused on rolling yours out as fast as possible.
The technology side, and then long term, it's going to be, for any of these technologies, regardless of how energy efficient you are per ton, which certainly is the focus of, I'm assuming, both of our companies, certainly is for us. Multiply that times 1 billion tons, and that's a heck of a lot of electricity, regardless of how efficient you are per ton. So that's just going to be one of the huge field changes. I think in China, the number is around 1/6 of the coal that's mined goes into steelmaking. These are huge energy sources, steelmaking using coal. And if that's going to be converted to renewable power, it's going to put a huge strain on that production. But that's no different than what you're seeing for transportation and everything else that's being electrified. So the pace at which renewables can be built out and all the supporting infrastructure and supporting technologies, we're pretty agnostic at Boston Metal in terms of where that clean power is coming from. Certainly certain different customers have a different take on that. But for us, that's one of the big variables that's out there in terms of how and when and where geographically you start to see green steel being deployed at larger and larger scale.
Yeah, and I think another barrier to, I guess, scaling up these technologies is the throughput of, at least on the hydrogen side. Adam can speak more on the electrolysis side. I think I mentioned that hybrids throughput is about 1,000 tons per year, if I'm remembering that right. And you need to essentially scale up 3 to 6 orders of magnitude to get that right. So ArcelorMittal and Midrex are building up a 100,000 ton per year site. 100,000 tons sounds like a lot, but if you're building billions of tons of something, you just need to have a higher throughput of that process. And I think Adam also talked about the ore grade requirements for hydrogen direct reduced processes. And hybrid has access to good Swedish ore, but most of the ore around the world would require upgrading and more costs on it. So I think David's work, actually, I really wish he could talk right now. His work in, I guess, matching the people willing to pay more for steel and getting a supplier and like having an advanced market commitment to say, yes, we'll buy some hundreds of thousands of tons, that will push people to build those cleaner facilities sooner. Something that I'm actually interested from Adam's perspective is those advanced market commitments, or those first buyers of your green products. I guess, what is the premium they're willing to pay? And I have my own experience talking to customers, but I'm curious about yours. But I'll let Rosie actually.
Yeah, well, everyone watching, if you're interested in procuring green steel, can you tell us, are you willing to pay a premium for that? And maybe, if you can suggest maybe the order of magnitude. I know we had a comment from Olivia Dippo, who is a co-founder of Limelight Steel with Andy. And she says that they're interested in hearing about what customers are looking for when they're making the switch to green steel. So you can definitely get in touch with her if you want to discuss that more. And Adam, I assume that you guys, I know that you're scaling up, you've got something very close to a commercial scale technology ready to roll out commercial like trial projects, I guess. I know you're still a few years away from the full industrial volumes, but are you looking for partners as well? And maybe you can tell us a bit about what kinds of, I assume you've got some lined up already. Can you tell us a bit about what kinds of customers that you're working with, and if there's any special, characteristics that make it a partnership a good match between you?
Sure. Yeah. So I can talk, some that are established and publicly known, if you look at our investor base and the steel value chain, there's an example at each bookend of that. So we have two of the iron ore majors, BHP and Vale, on the upstream side. So today, if you look at an iron ore producer, their scope 1 and scope 2 emissions are pretty modest. Their scope 3 emissions are immense because of how their product is used. It looks like, similar to an oil company or something of that nature. So there's a lot of investment focus and development focus from them to help support the industry. You're seeing, certainly you saw an investment in Boston Metal, but you're seeing MOUs across the steel industry where BHP and Vale and the other ore majors are partnering with steel makers to help enable this transition. Certainly also ensure that their ore products have a strong position in that generate production fleet of the future for steel. On the other side, we have BMW through their iVentures group, and that's the demand pull side for steel. And then there's certainly a bunch of you have steel. We're not a steel maker; we license technology. So you have the steel makers, you have the component suppliers in the case of automotive, the tier 1 suppliers, and then you have the auto OEMs like BMW. So that's where we've seen, really the demand and the interest, the market pull is across the whole supply chain.
Okay, cool. So I did just post a poll. Will there be a clear tech winner in green steel? Maybe I should have posted it before we started talking, because we've got 100% of people saying it's going to be a mix, which I don't know, maybe also that's just obviously the reality. I don't think that any one technology can, I guess some of them could feasibly take the whole market, but I mean, obviously we're going to keep on recycling as much as we can because it's just already, economically viable to do that. You make money by recycling scrap steel, and I know most countries, they will, take your used car away for free because there's value in that material, and there has been for a long time, a lot longer than before we cared about the emissions. So clear to me that electric arc furnace was going to take all that it can, but then beyond that, I don't think that there's any one technology that would be able to take the whole rest of it. So that's interesting. I have another viewer question from Vanessa Ferrero. Is there any research in capturing the excess heat in order to reduce energy waste? Thinking of a parallel to combined heat and power plants, but more like combined heat and steel. Not sure if this also helps reduce the emissions by replacing other processes used for heating outside of the steel plant. And of course, it would it would reduce emissions if you're currently burning gas or something. I guess it relies on either an industrial user of that heat or ability to connect to district heating or something like that. District heating is one of my technology obsessions. I lived in Denmark and we had district heating from combined heat and power nearby. That's kind of how they commonly do it there. A lot easier if you build it in from the start rather than try and go retrofit a suburb with district heating. But what do you guys think? Have you been involved in any projects to look at using your waste heat for something productive?
Blast furnaces already capture any heat coming off of the flue. So after you combust that coke with iron ore, CO2 is emitted, but it's very hot gas. So you can essentially capture that hot gas and use that heat in a heat exchanger to preheat your iron ore. Or preheat any of your other processes. So definitely that's a great way to think about it, as a combined heat power plant, I guess. So you're recycling that heat for sure. It's been optimized for that.
Mm-hmm. And Adam, at Boston Metal, do you have a lot of waste heat? I know that your your supply of electrons also is a supply of heat that your process needs. I mean, I guess every steel plant has waste heat because the steel comes out liquid, which means it's hot. Do you do anything with that heat, or could you do anything that you can
There's
think
certainly
of?
ways to think about optimizing that. So you have exhaust streams that are coming off. Oxygen is being produced every time you're splitting iron, so you're going to have that exhausting off at quite high temperature. You can look for ways to certainly utilize that efficiently, both the oxygen side of things and the heat that's associated with that. Some of the downstream heat from the steel that you're trying to, in our case, tapping a liquid steel, trying to be able to carry that directly downstream to the next process without cooling it, so you don't need to do reheating. And that's where that heat's being utilized. But from the exhaust streams, you certainly have heat. As a furnace, we try to be pretty efficient in how we insulate that to eliminate much of that waste heat from the core of the reactor. You're certainly not 100% efficient in that. But the biggest stream that's pouring off as more on the waste side would be the exhaust gases.
Okay, cool. We're actually pretty close to running out of time. So I just want to give you each 2 minutes, that's literal 2 minutes each, to talk about what people could do to get in touch with you, or what sorts of partnerships that you're looking for. I know we've got an audience of about 50 people that are looking for ways to decarbonize their steel supply chain. So you tell them how they can get in touch and what they can do. And we'll start with Andy.
Yeah, Olivia already dropped her email in the chat. If you want to reach out to me, I'm andy@limelightsteel.com. The main things that we are looking for are those first customers that would offtake the initial amounts of steel. So this is I think every company that is a startup has to figure this out, is as we scale the technology up, we will be producing on the order of hundreds of kilograms of it, which is not meaningful to an industrial decarbonization standard, but those are milestones that must be met as we scale up to the megaton region. But what do you do with that steel in the meantime? You could have a partner along the way to scale with you. So those first customers, I think, are super important. So anyone that wants to talk about procuring green steel, we're very interested to see what their specs are and learn about their verticals of what type of steel you need and what you're using it for. Very, very curious to learn more about that. I think if you are
cool.
I think that's
sorry, I'll just wrap you up and hand over to Adam for his literal 2 minutes.
Sure, very good. Yeah, and similar to Andy, the advantage of being in early at some of these companies is you can secure the first name email. So Adam at Boston Metal will get you to me. And if hopefully many of you that are listening have been to our facility in the past, so if you're interested in coming and taking a tour and seeing the systems we have, and maybe if you're lucky on coming on a good day, seeing some metal being tapped, please reach out and come and explore and see what we're doing. Thanks.
Yeah, highly recommend the tour. And Andy, when you guys are ready for a tour, then you get in touch and let me know, and I'll come over. Okay, so we're out of time, but I just want to point everybody's attention at the survey tab on the right-hand side of the platform. So the event organizers appreciate the feedback. Big thank you to the panelists, and also including David, who it must have been very frustrating for him. I know he had prepared some stuff to talk about, and I was really interested to hear his perspective because I talk to engineers all the time. But usually, no offense to you guys, very, very appreciative of your contribution as well. But I was keen to hear the political aspect of it as well. So maybe he can share his presentation that he was going to make online, and we can see it that way. But biggest thank you to everybody that signed in to watch, and thanks. We'll leave it there. Bye.
Very good. Thank you.